Hello friends, in this video we are going to learn storage classes in C. So before learning what is storage class, we will see what is a block. So all the statements covered by a pair of curly braces are said to be enclosed in a block. So one block is a starting curly brace and ending curly brace together make one block. So here we can see this is the start of the block and this is the end of the block. This is one block we have in the screen. So we can have n number of statements inside the block. I've just given 3 statements and given some dots. So it means that there can be more than 3 statements. It can be more than one statement. So one or more statements covered by a curly brace is said to be enclosed in a block. So we have a nested block. So what is nested block? Nested block is one block inside the other block. So here you can see this outer block. This is the start of the outer block and this is the end of the outer block. I've just given number. Actually there's nothing like numbers, block 1, block 2. I've just given here to make you understand that this is the block. You can call it as an outer block or block 1. So this is an inner block. Here we say start of block 2 and here this is the end of block 2. So the outer block contains inner block and few other statements. You can see the inner block is here inside the outer. This is the outside block or the block 1. Inside that we have a block 2 and also some statements. So the outer block or the block 1 contains block 2 and also few other statements. And block 2 contains only statement 1. That is, the inner block contains only the statement 1. So different storage classes in C are automatic, register, static and external. So we will see one by one. We will first see automatic storage classes. So automatic storage class is a class in which when you declare a variable, so the storage location will be memory. So when you declare a variable of type automatic or auto, it will be stored in the primary memory, that is RAM. And if you don't initialize value, when you declare a variable and don't initialize, there will be some garbage value in it, which is unexpected value. You would not know what exactly you will get as an output. It's an unexpected value. And the scope of the value, so where it can be accessed, that variable declared can be accessed only within that block. It can be accessed by that block and any block inside that blocks, but you cannot access the variable outside the block in which it is declared. So we will see this in some examples in this video. So what is the life of that variable? So when we declare a variable inside a block, so the variable is available to the user or it's alive till the block is executing. Once the control comes out of the block, the variable is lost. So that variable cannot be accessed again. So till the control is within the block, the automatic variable which is declared inside that block will be available. After that it will be destroyed. So we'll see one example. So in this example we have declared 2 variables of type int and also declared it as a auto. So when we print these values, we get some garbage values, unexpected output. So we don't know exactly what the values inside the m and n are. So we get some junk values. So in the example 2, I've declared a variable I of type int and also as auto. So now you can see auto int I is equal to 0 is a statement which is in the outermost block, that is the main block, the main function block. So it can be accessed within any blocks inside the main block. You can access within the main, within the inner blocks of the main. So within the innermost block of the main, you can access it from the innermost block. You can see this is one block. It starts here and it ends here. The second inner block is, it starts here, the middle block. I called it as a middle block. So it starts here and it ends here. So this is the middle block what I have done. There's nothing called inner or middle block. I've just given a name so that you can identify it easily. So the innermost block, you can see this is the innermost block. It starts here and it ends here. So you can access this I variable anywhere inside the main. You can access it here. You can access it in the middle block. You can access it in the inner block. So you can print the value of I anywhere you want. or make use of the value and calculate some values, you can use I anywhere inside the main function because it is declared in the main block. So now in this example, we have declared three variables of type int and the variable name is I. So I've declared one in main block, that is this is the main block from here to here. So this I can be accessed from anywhere inside the main block. So here we have declared in the middle block, we have declared I is equal to 0. This is the middle block, starts from here and ends here. So we declared one more variable I, and there's the innermost block we have. It starts from here and it ends here. We declared a variable I of type int here. So all these variables are there, but what happens when you print here in the innermost block? So when you print in the innermost block the value of I, so the innermost value, the local value will be printed. So this, if the I value is 4 here, currently all the values are 0. If the innermost I as 4, so this will be given preference. So whenever you say I, the program thinks that is looking for a local I, that is inside the innermost block. This is the innermost block. Inside you declared I variable, so this is first given preference. So if there is no I, next it will go to this place and it will print this value, this I value. And if there is no I, then it looks for the outermost block. So you should be careful. So whenever you print a value of I, so it will print the local value, it's given preference. When you print I here, you can see this is in the middle block. This is between this and this pair. So this will print this I value. So always the preference is given to the locally declared variable. So this is locally declared variable to the innermost block, and this is locally declared variable to the middle block, and this is locally declared to the main block. So if you don't have this and this statement, that is the I declared in the middle block, I declared in the innermost block, then this will be made use in all the inner blocks. So we will see register variable. So register variables are special variables. So whenever you are making use of a variable very often, for example, you are using a loop variable I every time and you're making use of loops many times. So if you want that value to be in the register, CPU registers, if the value is in the CPU register, if the variable is inside the CPU register, the access of the data is very fast. For example, you are using a value called pi 100 times or 200 times in a program. So you are accessing the value from the memory every time. So if you don't want to use a pi value, if you don't want to access the pi value from the RAM, you want faster access of pi value, so you can declare a variable pi and make it as a register variable. So the access of the variable will be very fast. So that is the reason why CPU registers are used. This is register variables are used. Sorry. So the register variables are used so that if a variable is being accessed more more number of times, so then it's unnecessary waste of time for accessing the variable every time from the RAM. So it is best to keep it in a CPU register. So what is the default value? Default initial value of a register variable is, it's a garbage value. So you cannot expect what value will be there in the in the register variables. If you declare a variable as a register and you don't initialize it and try to print the value, you get some garbage value, unexpected values. And the scope is local to the block, so it can be accessed only inside the block in which it is declared and all the inner blocks of that block. So you cannot access outside the block in which it is declared. So on this variable, the variable which is declared as register will be available till the control is inside that block. Once the control comes out of the block, so you cannot use that variable or you cannot access that variable. So that the life of the register variable is within the block. Sometimes if you declare a variable as a register variable, there is no guarantee that variable will be kept in CPU registers because there may be no space for this register variable, because the number of registers in the CPU is limited. There can be 10 or 20 or 30 registers in a CPU. If it's already filled, so CPU cannot allocate the new register for this register variable. So it is not guaranteed even if you write a register int x. So x may be stored in the memory only, it's a physical memory RAM only, because there is no space available, no registers available for the storage. It's already filled up or already filled up by other programs. And some other times, like if you are declaring a variable of type double, so the variable of type double holds the size of the double variable is 8 bytes, and if the CPU registers are 16-bit, that is 2 byte, so it cannot hold a bigger value as a register variable. So you will not get any errors, but still we can execute the program. And the double, if you declare a double variable and the CPU processor contains registers of 2 bytes type, it cannot hold a 8 byte variable in a 2 byte CPU register. So in that time, it will be stored as an automatic variable. It will not be stored as a register variable. It will not be stored in CPU register. It will be stored normally as a automatic variable in the RAM, that is the physical memory. So when we don't declare, when we don't initialize, it will be a garbage value and it will be local to the block, similar to the automatic variables. So the life is similar to the automatic variables. It's the life of the variable is, if you declare it's inside a block, it exists until the control is within the block. So when the control comes out of the block, the variable or the variable which is declared as a register cannot be accessed. So here's an example. We can declare it. So most of the times, if we are using I for more number of times, we can use that as register variable, or we can use M and N or register variables. There's no change in the output. It's simple. It's a garbage value. You get a garbage value from this. It prints 10 times the garbage value of M and N. So it's an unpredictable value, whatever is printed in M and N. So there's no use of for loop here. This is just an example which shows a default initial values, garbage values. Even without the for loop, we can just print one time the garbage value. So it's just given that if you want, you can use this I as a register variable so that you are using more number of times in a program. So then comes the static variable. So the static storage class, the storage of the variable declared as static is RAM, that is memory. The default initial value is 0. Even if you don't initialize a static variable, you declare a variable static int x and don't initialize it, that still the value will be 0. The default value given to a static variable is 0. So you can make use of the value and you know exactly, can predict that the value will be 0 in the static variable if you don't initialize it. And the scope of the static variable is local to the block, similar to automatic and register. So the variable declared as static is available only in the block or within the inner blocks of the block. It cannot be accessed outside the block in which it is declared. So only if you declare a variable in a block, you can access it. Outside the block, you cannot access it. The life of the variable is the value of the variable is persistent during the function call. So this is one of the important feature of static variable. If you declare a static variable in a function, you call the function once, so all the variables come into existence, and after the function call ends, after the function execution ends, it comes back to the calling function. When it comes back to the calling function, the called function, all the values will be lost. But when you declare some variable as static, so the value is not lost. So if you call the function again, so for the second time, that static variable value will be still available on the second function call. So we will see this example in the next video. In the next video, we've declared a variable as static in a function and we have used it. You can see it in the next video. So static values, here you can see static int mn, and if you print the values we get 0 and 0 because static variables or the static storage class has a feature that all the variables declared as a static should have a 0 as initial value. Even if it's not initialized, it will be 0. So the last type of storage class is external. So external storage class, the storage location is RAM. So whenever you declare a variable as externals, actually you don't have a keyword called external, so you will be declaring outside all the functions, even outside the main function. So this is also called as a global variable. So when you declare this, it will be accessible by all the functions. So the default initial value is 0. Scope is global, that is you can access it from any function within the program. If you declare one variable int I is equal to 10 or 0 or any value outside all the function, even outside the main function, that will be accessed by inside the main function or inside any other function. So this example will also be shown in the next video. And this program will variable, the external storage, the global variable, is available throughout the program. It's available throughout the program. So until the program is execution is taking place, until the program execution is taking place, the value will be available, the variable will be available. So once the program ends, the global variable are lost. Friends, we will see some programs in this video. So we till now we saw the storage classes. We'll see some examples of storage classes. So here we have an auto keyword for an automatic storage class, and if we print the value, I'll say Alt F9. So we have two warnings here. You can see possible use of m before the definition in the function. So you can ignore this because we have not initialized it. So it's giving a warning. So when we compile, you can see the values are unpredictable. 191258943. We have never initialized the values m and n, but we still get values. So these are unpredictable values. So garbage value, you can call it as a garbage value or junk values. So then we'll see the second example. So here we have declared a variable I is equal to 3 outside all the blocks. You can see this is the innermost block. There's only one statement inside the innermost block. So the middle block, you can see this is the middle block. Middle block contains one inner block and one printf statement. You see this is the middle block and this is the outermost block. This is the main block, main function block. So you can see one variable declared here. So one block is declared here and one printf statement. The inner block has one more inner block and one printf statement. So you can see this is the outermost block, this is the middle block, and this is the innermost block. So you can access I anywhere inside the main function. So because the I is declared inside the main function, you can access anywhere you want. You can access in innermost block, you can access inner block, middle block, you can access it in the outermost block. When we do Alt F9 to compile the program and Control F9 run the program, says you get 333 as a output. So save this program. So if we change the value here 5 and say Alt F9 to compile the program and Control F9 to run the program, you can see it prints 555 in its innermost block 5, middle block 5, main block or the outer block is 5. So it prints the same value in all the blocks. So we'll see the third example. So here I'm declaring, so I can write a comment here. It's in main block. So comments are not affected, not included in the program when compiled. It's in middle block. It is in innermost block. You can see this I is innermost block. So when I print the innermost block I inside here, so I don't want to have this clutter here. Okay, I just kept it on the side. So now you can see this I is declared in the outer main block or the outermost block. This I is declared in the middle block and this is innermost block. So whenever you access a I variable from innermost block, it will be printed 4. So if you access I from middle block, so the middle block value, this I will be printed and this I will not be printed, or this I will not be printed. So if you print any value I, so the local value I is given preference, because this I declared is, you're printing I from the outermost block. So if you print an I from the outermost block, it will first preference is given to the outermost I, that is the local. This it will first check the local I, so it will print the I. Again here in the middle block, you're in the innermost block, you can see it's printing I, so it will first check the local I. So this is the local to this block. This block, you can see this is the block, and this I is local to this block, and this I will be printed. And again here you are printing I value in this statement. So in this statement, this is the block and this I is local. I is equal to 2 is local to this block. So this I will be printed in here. So we'll see this program. We'll compile Alt F9 and Control F9. So you can see when I print innermost block, it prints 4. The local I is given preference. It's not printing the outermost I or the middle I. It's printing the local I. And then in the middle block, if I print I, so it's giving preference to the middle block I. And if we print main block I, it prints the main block I. So local variables are first given preference. So we'll see one more example. This register variable, you cannot see any output related to the register variable, whether it's placed in a register or not. You can just see the default initial values. I'll compile this program. So here you can see we are getting a warning. It says possible use of M before definition. So you get a warning whenever you don't initialize a value and try to print it. If you're trying to print a value which is not, you get a, so you come, if you can I run the program using Control F9, you get an unexpected value, say 3162, 3204. So we did not declare the value, initialize the value with a 3162 or 3204, but still we get the value. These are called garbage values or junk values. So the last one would be the static. So we have declared a static variable here. If I do Alt F9, so you can see here we are not getting warning here. So static variables, even if we don't initialize, it will not give us warning. It will by default give us 0 value for non-initialized static variables. If you declare any variable, you can see you're not getting warnings here saying that the possible use of M and N before initialization. So we're not getting any warnings. It says it's okay, the program is fine. So when you compile this program, you get 0 and 0 as output. So by default, static variables get 0 and 0 as values. We did not initialize value by 9. We don't get warnings also when we don't initialize static variables. We compile this program, we get 0 and 0. Compile and run the program. Friends, in this video we will learn about storage classes in C. So in the next video you can see the use of a static variable and the global variable, that is external storage class variable. Thank you for watching this video.